Hey kids. Alright, so we're reviewing for the final part of your final, which is going to be a multiple choice test, but we all know that doesn't necessarily mean easy, so pay careful attention to the skills that you're going to need to know. First, we're going to give you two functions. In this case, we have f of x over here and g of x here. And then the operation I'm asking you to do here is I want you to multiply them together. So we remember from a pretty recent test that multiplying together binomials means we need to use parentheses, and then we're going to distribute. So 4x times x is 4x squared. And then we've got, what, a minus 36x. And then over here, a plus 5x. And then finally, a negative 45. Now this will not be an answer choice because it would not be the simplified version. We're going to want to add these together. And then on a multiple choice test, we'd be looking very carefully for 4x squared minus 31x minus 45. Now remember, any slight mistake you can make on there, the common ones are going to be choices, and that's what makes these kinds of tests so tricky. Alright, then we're going to be factoring. Now, you're going to get to use your factoring flowchart. And when we look at this pattern, I can see it's a difference pattern. There's no common factor, so it's got to be one of our special binomial patterns. And it looks like this particular one is the difference of cubes. I can tell it's cubic, mostly because it's x to the third, but also that 8 and 27 are cube numbers. So speaking of that, the way the cubic pattern works is you've got a cubed minus b cubed, and you want it to look like this. You want it to look like a minus b times a squared plus ab plus b squared. And that's taken straight off the factoring flowchart. So what gets tricky is you got to remember who's a and b, which means you got to cube root this guy. So cube rooting 8x to the third is going to be a 2x. And then cube rooting a 27, remember not the negative, that's part of the formula, just the 27 is going to be a 3. So now plugging in the numbers where they belong, you're going to get a cubic pattern. So we have 2x minus 3. Should have put the signs in, hold on. Plus plus. And then a times a is how I want you to think of that. So 2x times 2x is 4x squared. And then multiply them together, that would be what, a 6x? And then b squared 3 times 3 would be a plus 9 on the end. So the cubic pattern is really nice and easy as long as you recognize it. First of all, you're seeing the cubic pattern and you know how to use it. Again, multiple choice tests, so I'm going to be really tricky and kind of put distractor answers in there. Okay, here's a vocab question. Write 2 examples of a cubic polynomial. So a bunch of things you could write for me. I'm going to write a really boring one here. 2x to the third. There's one example. And then how about like x to the third plus 2x squared minus 1. That's another cubic polynomial. And what makes them cubic is that the largest exponent that you see in the polynomial is a 3. And that is in reference to what's called the degree. Whatever the degree is, that's the highest exponent, and that also gives you a name associated with that. So cubic is degree 3, quadratic is degree 2, quartic is degree 4, quintic is 5, you know, all that good stuff. Alright, this has been a minute since some of you have seen this question. They want us to find the remainder, which means we need to divide this by this, and you can choose your method, but if I had to take a guess, I would say most of you are going to use synthetic division. So you're going to take the divisor, which is x minus 4, and you're going to find the solution to the divisor, which of course would be adding 4 to the other side, so x equals 4. And that's what you're going to put in the little half box over here. Now the next thing you're going to have to do for me is take your polynomial, your dividend, and then write the coefficients. Make sure they're in standard form order and you're not skipping over anybody. If you skip a term, you got to put a 0. So we've got cubic, quadratic, linear, constant. Looks like we got them all. So the coefficients would be 2 and a 1 and a negative 4 and a 3. So this is the setup for synthetic division. I'm choosing not to do long division because you guys told me pretty loudly and proudly you didn't like it. And the way it starts is you bring down that first coefficient as a starting point. And now it becomes just a simple multiply and add type of a problem. So you're going to multiply this 2 times the box and get an 8. And then you're going to look at this like an adding problem, like in a column. So now you're going to add these two things together. So 1 plus 8 is of course 9. And then you just repeat it again. So now 9 times 4 is 36. I think when I made up this problem, I didn't realize how crazy the remainder got, but you know what? It's okay. -4 plus 36 is 32. And then, okay, brain, do smart things. Here we go. 4 times 32 is 128, I think. And then when I add those together, I get 131. And the remainder is always the last number in your synthetic division process. So that guy right there is your remainder. So again, multiple choice test. You go through the work. Hopefully you find your remainder as one of the choices. Otherwise you messed up. And again, just because your answer's there doesn't mean you're right. I could be trying to trick you. All right, so here we have some more vocab questions. Is this growth or decay, and can you tell me why? So of course you can graph it, and you can see the shape of it, but an easier way to determine whether it's growth or decay is you look at the base. So your base in this problem is 5 halves, also known as 2.5. And since the base is greater than 1, that means you have a growth function. The other thing I want to point out is if you typed this on your calculator, 1/3, and then in parentheses put the 5 halves to the x power, you'll notice, just like our previous test, we saw this a lot, where there's no vertical shift, right? So the horizontal asymptote is going to be at 0. You don't really need to graph this full out to know what's going on. If you've got a horizontal asymptote at 0, and you know it's growth, I mean, I don't know exactly what it looks like, but something like this. Of course, graph it on your calculator if you're not sure, because there's going to be a question, again, multiple choice, so look carefully at your choices. The domain is an easy option because it's always going to be -infinity to infinity for exponentials. The range is the one you got to think about. So remember, the range is going to start at the asymptote, but not get there, so you got to use a parenthesis. So it starts at 0-ish and then goes up to infinity. Again, it's multiple choice, so you got to look really, really carefully, because I'm sure I'm going to try to trick you with a choice that looks close but not quite right. All right, so here they want us to use this formula, so that's helpful, and then actually get an answer this time round to the nearest cent. So they give us some information. Let's read through it. Cost of bread is exponentially increasing at a rate of 1.1%. Now, right there, the 1.1%, you have to take the 1.1 and divide it by 100, or move the decimal point over twice. Make sure you're using this as your rate when you're in your calculator. Now, it measures years, like it pretends time starts in 1995 for this model. So originally, the bread costs $1.25. That's the original amount that we're going to put right there in the formula. And then they want us to predict the price in the year 2025. So if you think about how much time has passed, oh my gosh, this makes me feel very old now. That would be 30 years from 1995 to what is it, just a couple of years from now, 2025. So what you'd want to do at this point is, first of all, you guys know what bread costs, and I'm sure whatever the problem is, it's more well, it's kind of realistic, I guess. If you see an answer that's like totally crazy, just don't choose it. Obviously, the bread price is going to be higher than $1.25. So on the home screen of your calculator, what you're going to type in for me is 1.25, and then 1 plus 0.011, and then raised to the 30th power. Now, of course, if I was a good person, I would have already done this, but I didn't. So let me hurry up and calculate it on my phone, because this is not something I would expect y'all to do in your head, and I'm surely not going to. I'm going to guess it's like $4. I don't know. Probably not. Oh, I feel like I messed something up there. I'm getting $1.74. Oh well, alright. Makes sense to me. Was it close? Okay. So, when we type that in our calculator, make sure you're in your home screen. A lot of you go to your table, your y equals in your table to do this problem. Not necessary, since you know how much time has elapsed. You don't need to do that. Alright, I'm going to retype that in. I feel like I did something silly, but I guess that is the right answer. Never mind. Alright, so this one, they want you to find the solution. There's a few ways you could approach this. Now, we know when we're solving a logarithmic equation that we exponentiate. So whatever the base is, we're going to use that to exponentiate both sides of the equation. And that's going to give us, let's see, those 5 to the log base 5 will cancel, and 625 equals 5 to some mystery power. Your job is to figure out what this mystery power is, And remember, it's multiple choice. So as you look through the choices, you could just be like, oh, if I plug in A, does it work? Or B or C. The other thing you can do is just anticipate what you think the answer is. 5 raised to a power is 625. I know you used to have a chart for this, but we're not going to be able to use that chart anymore. So maybe just try some things on your calculator, and it turns out the answer is 4. Now, there's other ways for us to get that answer. You could use some change of base formula. I think for where we're at right now in Algebra 2, I think this is the best method for you to solve that problem. All right, completely expanding logarithms. We are going to want to look for an answer that's fully expanded, which means in each logarithm, you're only going to have one thing. So first thing I notice is we have a division problem. So when you have a quotient inside of a logarithm and you go to split that up, that becomes a subtraction problem. So the log of the numerator minus the log of the denominator. Now that's still no good, because then when I look inside this logarithm, I notice it's got a multiplication problem. So we're going to have to split that up, and that becomes the log of the first thing plus the log of the second thing. And I haven't done anything to that last logarithm yet. We'll talk about the exponents on our next step, like right now. So now any exponents or powers, they get rewritten down in front of their logarithms. And that's usually the last step I do in these problems. Now I'm going to go ahead and rewrite all this, and then I'm going to come through with some colors and kind of show you where everything was coming from. But we just utilized all 3 properties of logarithms. Remember, this will be a multiple choice question. So if you know what you're looking for, you can kind of deduce your way to the right answer. This subtraction problem was because of the original division, and then we just kind of carried it through the problem. And then here, when we had the multiplication inside the logarithm, when we split that up into an addition problem, again, that carried through the problem. So again, it's multiple choice. So if you know what you're looking for, you can probably figure out what answer it is without showing too much work, but there's nothing wrong with showing tons of work on these tests, because sometimes you make a little whoopsies and I can give you partial credit. Even though this is multiple choice, I wouldn't mind looking for partial credit. All right, this problem, definitely you're going to need a calculator. This is a weird, it's the birthday money question. So they don't tell you how much birthday money, so we're just going to pretend that we always get $100. Makes for easy typing and easy logical math. And then we have interest of 3.2%. compounded quarterly. That's an important feature in a minute. So this rate, this 3.2%, remember it's divided by 100, or move the decimal point over twice. And then when it says quarterly, that tells you how many times a year you're going to collect interest. So that means 4 times a year. N equals 4 in this problem. And then this is where it gets kind of tricky. It says how many years. So because we don't know how many years, we're going to have to use our table. Again, you can also use logic. When you look at the answer choices, some of them are going to make absolutely no sense whatsoever. So when I put my numbers where they belong, my initial principal technically could be anything. I'm going to use 100. And then 1 plus our rate is 0.032. You have to divide that by the n, number of times that you're going to collect interest, which is a 4. And then up in the exponent position, that 4 shows up again. And you're supposed to multiply it by how many years, but since we don't know how many years, I'm going to have to call that an unknown thing. I'm going to have to call it x. So our next task is to get this typed into y1. So if we type that into y1, this whole function here, and please, for goodness sake, don't forget your x up here. When we go to our table, we're going to look for our money tripling, right? It said triples. So we're going to need to look for about $300 in the y. And again, I don't have this done. So let me hurry up and do that. So what do we have? $100. Oops. 1 plus 0.032. I'm using my phone calculator and it's just awful. I have a screen protector on it that Mr. Abruzzo made me get, and stupid finger things in the middle of my keypad. Shout out to Mr. Abruzzo. Alright, so I'm checking out for my money to triple. Oh my gosh, some Yahoo has their table set up at 1,000. Let me go fix that. Okay, now I'm going to look for my money to triple. And I'm scrolling for a little bit. Triple is going to take a while, especially at a low interest rate like that. So don't be surprised if you're like in the 30s, 40s, 50s in some cases. All right, we're getting there. And triple, all right, about 34 to 35 years. And again, your answer choices are going to be multiple choice. So you're going to look for one that looks reasonable first, and then also one that matches what you're getting in your calculator. If your calculator is showing you something unreasonable, then that tells you that's a user error issue and you typed something wrong. All right, we're going to simplify this one. Now, these are all monomials. There's no factoring. We encourage you to kind of smush this problem together. So I'm going to smush the numerator and the denominators together into one massive fraction, and then we'll worry about reducing it. So coefficients here, 3 times 12, we're going to go ahead and smush those and make a 36 as a new coefficient. And then you've got x to the 6 times x squared, so that's x to the, we're going to add those together, so x to the 8th, y to the 4th, over, and then there's only one coefficient in the denominator, so I'm going to use that as a 10. And then I don't like the order, I'm going to switch it up a little bit. I'm going to put the x before the y, just so they line up so nicely. And this is where I'm probably going to trick some of you, and I'm going to do it on purpose, so watch out. The coefficient for this division problem, you need to actually divide them. These are not exponents, these are coefficients. So if you took 36 divided by 10, and it could be as simple as you math enter on your calculator. Let's see, 18 over 5, I think that comes out to. Divide them both by 2. And then here, again, another place where I might trick you, so watch out. We know we're supposed to subtract the exponents when we divide bases like this. So 8 minus a negative 2 is a 10. A lot of kids tell me that's a 6, and that's where I'm going to catch a few of you, so watch out. And then here, when we subtract these, you get y to the 0, which remember is just a 1. So you don't have to say times 1, they end up canceling out, and there's already stuff in the fraction, so we can just leave it alone. That question looks easy, but it's actually very easy to trick you, so look out. All right, 13, they want you to simplify this. The reason those polynomials are in parentheses is because I'm expecting you to know how to factor those. So pretty basic factoring here on this first one, a trinomial. Just watch your signs. I'm trying to multiply to negative 10. I want your arches to add up to negative 3. So since you have to multiply to a negative 10, you need opposite signs. And then, oops, yeah, I almost tricked myself. That's a positive 2 and a negative 5. That will add up to negative 3. And then in the denominator, when you factor that guy, that's just a difference of squares, a good twin, evil twin question. So x plus 5 times x minus 5. And then you look for cancellation. So the x minus 5s are going to cancel. So my advice to you on this question is to go slow and triple check that you factored correctly before you start hacking away, because like what I originally was about to do, which was screw up my signs, I am positive that that would have been an answer choice as a distractor. All right, so here we have a quotient problem. Again, those parentheses indicate that you got to factor something. But first we have to remember when we divide rationals, we have to change it to a multiplication problem. And the way we do that is we take the reciprocal of the fraction that follows the what used to be a division sign. So x plus 4 over 1 is now multiplied by, now I'm going to multitask here. I'm going to flip it, but I'm going to factor at the same time. So here we have a pretty basic trinomial, trying to multiply to negative 15, so I need opposite signs. I want them to add up to negative 2, though. So how about we do a positive 3 and a negative 5. And then now what is going to be my denominator, all positive signs this time, which means my factors will have positives. And then multiplies to 12 and adds up to 7 would be a 4 and a 3. All right, so now that you have a multiplication question that's all factored, you have a giant multiplication question, and the fun can start. You're going to cancel out anything that shows up in the numerator and the denominator, and all you're going to be left with here is a silly x minus 5 over 1, which we're just going to write as an x minus 5. It's in the numerator. All right, next question. I'm not asking you to add. I'm just asking what the least common denominator is. So the key to this question is to understand, all right, these are factors. They are not further factored in any way, which means they are their own terms. So your least common denominator would need both of those factors. You would need a 3x plus 2 and an x minus 5. This is the question. This is the answer that I would be looking for. It's not going to be written as a denominator necessarily, but you need to make sure you're incorporating all the factors. And before you look at the factors individually, you got to make sure that your original denominators are not factorable, which these ones weren't. All right, so here we have an equation. We're going to be solving it, so we're going to use our LCM. And when they say extraneous solutions, that has to do with the phrase excluded values. So remember, the easiest way for us to look for excluded values is to find our LCM first, which for this question is pretty basic, it's just x plus 3. And then your excluded value is going to say whatever your LCM is, it can't come out to equaling 0 because that would produce a 0 in your denominator. So if you solve this little anti-equation, you get x cannot be negative 3. So just kind of keep that in your back pocket when we solve this equation. If we get x equals negative 3, we're going to have to cross it off and not count it as a viable solution. Alright, so now the fun. Big parentheses around the whole problem. You're going to multiply through by your LCM. And then I think most of you can take the shortcut on this problem. However, if you can't, I'm going to write it out the long way right here. So it's going to take us a little bit of writing, but I think for some of you it's really worth it because it gets you the right answer, which is what we're looking for here. So the LCM is going to be distributed to each term, including that 6, which is 6 over 1. And then don't forget the end of the problem as well. Now this is where we have those little multiplication bubbles. Each one of those distribution problems becomes its own little simplification problem. So you're going to have to look at each one of these and determine if there's anything you can cancel, simplify, distribute, whatever the case may be. So when I look at that first multiplication problem, I notice this x minus 3 and this x minus 3 are going to knock out. That's the whole point of the LCM, is you need the denominators to knock out, and if you don't get that, you screwed up. So this first bubble, all that's left is 2x over 1, so I'm just going to write down the 2x. Now in this bubble, I have an x plus 3 times a 6. I mean, the 1s are still there, but that's not really a thing that I have to worry about in a denominator, so I'm just going to say this is really x plus 3 times 6, but go ahead and distribute that. So call it a 6x plus 18. And then finally, in this last bubble, the x minus 3s are going to cancel like they're supposed to, and all you're left with is a 3. So now what you got is a multi-step linear equation to solve. Maybe clean this left side up a little bit. 2x and 6x. Oh my gosh, so many of you are calling this something weird. This is just 8x, guys. So 8x plus 18 equals 3. And then we're going to divide both sides, subtract both sides from 18 from both sides. Hello, words. 8x equals negative 15. And then finally, I'm going to divide both sides by 8. Now remember, a long time ago we said x cannot be negative 3, and we surely did not get that as an answer. Negative 15 over 8 is our solution, and we get to keep it. All right, so probability questions. We're rolling a 6-sided number cube, so our options are 1, 2, 3, 4, 5, and 6. So the question is, what's the probability that you roll a number less than 3? So numbers that are less than 3 would be these guys right here. So the probability of that occurring is 2 out of the 6 outcomes, which they're not going to give you that as an answer. It's either going to be a reduced fraction, decimal, or percent. So we would want to write that as a 1/3. All right, everyone's favorite problem, the 2A table. All right, so we have data given in a table with totals on it. And then I have 3 different questions for you. The same 3 questions we keep asking: an and, an or, and a given. So when it says and an or, right off the bat, I know my denominators for those, they're going to be the big total. So I'm going to go ahead and put it out of 66 for both of these denominators. It's not going to be true for the given conditional question, so hold on to that one. All right, female and senior. So the intersection of female and senior would be these 8 ladies right here. So 8 out of 66. Let's see, if I reduce that, that would be what, like 4 out of 33? I think that reduces to. All right, female or senior. This is the one that tricks a lot of you. So here's our females, right? There's 34 females. And then here's our seniors. There's 22 seniors. But the problem with just saying, okay, I'm going to take 34 and add it to 22 is you've counted these 8 senior females twice. So you're going to have to subtract that. All right, let's see. 56 minus 8, 58, I think that came out to. And again, if it reduces, you're going to want to reduce that. 25, 29 out of 33, I think that comes out to. All right. I feel like I definitely added something wrong there. Let me double check on my calculator. I know better than to do this. It's way too early in the morning to do this in my head. I know you guys are laughing at me. I know. It's 48. See? For Pete's sake. How embarrassing. All right. Like I said, guys, that was 48, which is 24 out of 33. Goodness, math teacher. All right. And then finally, we have conditional probability where it says, given that it's a senior, it's the probability that they are a female. So what that means is no, not that either, Bruzo. Try again. Given that they are a senior, you're only allowed to look at senior data. Okay, given they are a senior. So how many total seniors do you have? 22. So out of those 22 seniors, what's the probability that you would select a female? That would be the 8 out of the 22, which again would reduce to 4 out of 11. That was a lot of mental math and a dangerous way to do it, Abruzzo. So hopefully I didn't mess up too much on those. The process was solid, but can't promise my computation is right. So that is your multiple choice part of your final, your third part of your final, 20 more points coming your way. But remember, multiple choice does not mean easy. Multiple choice actually means a little trickier than normal. So you need to slow down and think about how you get the question right. And sometimes it's even fun to anticipate, like, ooh, look what she tried to trick me with by putting that answer there. I mean, I wouldn't waste your time doing that for all the questions, but it is a little empowering when you look at a question and you notice that you don't get tricked by the distractor. All right, good luck, everybody. It's been a great year. Thank you much.